Imagine a world emerging from the shadow of the dinosaurs, a time when new forms of life were just beginning to claim their place on a recovering Earth. This was the Paleocene epoch, a period that started roughly 66 million years ago, right after the Great Extinction event that wiped out so many incredible creatures. In this new world, a different kind of giant rose to power. It wasn't a dinosaur, but a reptile of truly epic proportions. This creature was Titanoboa, the largest snake that has ever slithered across our planet. It represents a fascinating chapter in Earth's history, a time when life began to experiment with size and scale in ways we are only just beginning to understand through the amazing window of the fossil record. When we think of giant snakes today, our minds often go to the mighty anacondas of South America, or the long reticulated pythons of Southeast Asia. These modern snakes are impressive predators, masters of their environments. Titanoboa was related to these modern giants, specifically to boas and anacondas, but it took size to a completely different level. It was a true monster, a serpent so immense that it pushes the limits of what we thought was possible for a snake. Studying Titanoboa is like looking back in time and seeing a real-life legend, a creature that ruled its ecosystem not with sharp claws or powerful legs, but with sheer size and constricting force, a true apex predator of its time. To truly grasp the scale of Titanoboa, we have to travel back in time about 58 to 60 million years. This was an era when mammals were just starting to diversify, but they hadn't yet grown to the massive sizes they would later achieve. In the lush tropical wetlands of what is now South America, Titanoboa was the undisputed king. The disappearance of the large predatory dinosaurs left a power vacuum in many ecosystems, and in this particular corner of the world, it was this colossal snake that stepped up to fill that role. It was a time of evolutionary opportunity, and Titanoboa seized it, growing larger than any snake before or since, a testament to the incredible adaptability of life on Earth. Let's put its size into perspective. The largest snake living today is the green anaconda, which can reach lengths of around 20 to 22 feet, and in very rare cases, perhaps a bit longer. They are incredibly powerful animals. Now picture a snake more than twice that long. The average Titanoboa measured an astonishing 42 feet from nose to tail and weighed around 2,500 pounds or well over a ton. It was longer than a school bus and heavier than a small car. This wasn't just a big snake, it was a completely different category of giant. Its sheer mass and length made it a force of nature, a creature that would have dwarfed any snake we could possibly encounter in the wild today. The story of Titanoboa's discovery is almost as incredible as the animal itself. It begins not in a pristine jungle, but in the depths of a massive open-pit coal mine in northern Colombia called Cerro Jaune. For years, miners had been digging through layers of earth, unknowingly passing through a fossil treasure trove that held the secrets of a 60-million-year-old rainforest. It wasn't until around 2004 that scientists began to systematically explore the mine. A geology student first noticed a fossilized leaf that hinted at the ancient ecosystem, but soon, much larger bones started to appear. At first, paleontologists thought they might have belonged to some kind of giant prehistoric crocodile. The true identity of the bones was a shocking revelation. As more fossils were collected and examined, a team of scientists, led by paleontologist Jonathan Block and snake expert Jason Head, realized they were not looking at a crocodile. The bones were vertebrae, the backbone of an animal, but their shape was unmistakably that of a snake. And these were no ordinary vertebrae. They were huge, bigger than anything they had ever seen. By comparing these massive fossilized vertebrae to the bones of modern snakes like the anaconda, they were able to calculate the unbelievable size of the creature they belonged to. They had found a monster. The team named their discovery Titanoboa carrageensis, which literally means Titanic boa from Cerrejón, a fitting name for such a behemoth. The Cerro Jaune mine proved to be an incredibly rich site. Over time, the remains of about 30 different Titanoboa individuals were unearthed, giving scientists a fantastic look at this extinct species. Most of the fossils were vertebrae and ribs, the sturdy bones that are most likely to survive for millions of years. But the ultimate prize came later, a nearly complete skull. Snake skulls are incredibly fragile and rarely fossilized, so finding one was a major breakthrough that helped scientists understand more about how Titanoboa lived and hunted. This discovery completely changed our understanding of the limits of life. Before Titanoboa, scientists had theories about how large a cold-blooded animal like a snake could get, but this fossil shattered those ideas. The sheer volume of fossils from the Sarajevo mine allowed researchers to build a detailed picture of not just the snake, but its entire world. The mine yielded fossils of giant turtles with car-sized shells, massive prehistoric crocodilians, and huge lungfish. It was a complete ecosystem frozen in time, and at the very top of its food chain was the undisputed ruler Titanoboa, a predator perfectly adapted to its ancient swampy kingdom. So how could a snake get so incredibly large? The secret lies in the climate of the Paleocene epoch. Titanoboa, like all modern snakes, was a poikilotherm, or what we commonly call a cold-blooded animal. This means its body temperature and metabolism were directly influenced by the temperature of its environment. For a creature to reach and maintain such a colossal size, it would have needed a consistently hot climate. A colder environment would have slowed its metabolism down too much, making it impossible to support a body that weighed over a ton. Its gigantic size is therefore a direct clue about the world it lived in. Scientists used the size of Titanoboa as a kind of prehistoric thermometer. By calculating the metabolic energy required to sustain such a massive reptile, they estimated that its environment must have had an average annual temperature of around 90 degrees Fahrenheit, or about 32 degrees Celsius. This is significantly warmer than the average temperature in the tropical rainforests of South America today. The world of Titanoboa was a sweltering, humid place, a giant natural greenhouse. This extreme heat, which may seem uncomfortable to us, was the key ingredient that unlocked the potential for this snake to evolve to such an epic scale, a perfect example of how climate directly shapes life. The fossil evidence from the Sarajevo mine paints a vivid picture of this hot, wet world. Titanoboa lived in a vast, sprawling system of swampy rivers and deltas that emptied into an ancient sea. It was an environment much like the Amazon or the Mississippi River Delta, but supercharged by the intense heat. The landscape was dominated by water with lush tropical vegetation, including some of the earliest known rainforest plants crowding the banks. This aquatic setting was perfect for Titanoboa. Moving a 42-foot-long, 2,500-pound body on land would have been slow and difficult, but in the water, it would have been a graceful and powerful swimmer. Just like its modern anaconda relatives, this watery world was also teeming with prey. Titanoboa was an apex predator, and its diet would have consisted of the other large animals that shared its habitat. The fossils found alongside it give us a clear menu. It likely preyed on giant turtles, which had shells the size of a small dining table, as well as several species of prehistoric crocodilians. Unlike modern anacondas that sometimes prey on land animals, Titanoboa was likely a specialized aquatic hunter. It would have spent most of its time submerged in the murky water, waiting patiently for an unsuspecting victim to swim by before launching a surprise attack with incredible speed and force. Imagine the hunting style of this prehistoric giant. Much like a modern anaconda, Titanoboa was almost certainly an ambush predator. It would lie motionless in the shallow, murky waters of the river, with only its eyes and nostrils breaking the surface. Its massive body, camouflaged in the dark water, would have been nearly invisible. When a large fish, a giant turtle, or a 10-foot-long crocodilian swam within range, Titanoboa would have struck with explosive power. It wasn't a venomous snake, its weapon was constriction. It would wrap its immensely powerful coils around its prey, and with each breath the victim took, the snake would tighten its grip until the animal was subdued. The discovery of a Titanoboa skull provided crucial insights into its feeding behavior. While its body was enormous, its skull was proportionally smaller and more specialized than scientists initially expected. This suggests it was likely a piscivore, meaning its diet was heavily focused on fish. The rivers it lived in were home to massive, air-breathing lungfish that could grow to be very large. While it was certainly capable of eating crocodiles and turtles, it may have primarily hunted these giant fish, which would have been an abundant and readily available food source in its aquatic environment. This specialization highlights how it perfectly adapted to become the top predator in its watery domain. The existence of Titanoboa provides a crucial piece of the puzzle about what happened on Earth after the dinosaurs. The extinction event that occurred 66 million years ago cleared the stage, creating ecological niches that were suddenly vacant. In the hot tropical wetlands of Paleocene South America, there were no large land-based carnivores to fill the role of apex predator. Instead, this giant reptile stepped up. For millions of years, Titanoboa reigned supreme in its ecosystem, a testament to the incredible ways life can bounce back and diversify after a global catastrophe. It was a unique window in time when a snake became the biggest and baddest animal around. Ultimately, the reign of Titanoboa came to an end. As the Earth's climate began to cool over millions of years, the conditions that allowed this snake to grow so large slowly disappeared. The sweltering greenhouse world of the Paleocene gave way to cooler, more variable climates, and the giant snake could no longer sustain its massive size. Its story is a powerful reminder of the deep connection between life and the environment. Titanoboa is not just a monster from a bygone age, it is a symbol of a different Earth and a key that helps us unlock the history of our planet's climate and the incredible resilience of life.